Hello, and welcome to today's ACM Tech Talk. This webcast is part of ACM's commitment to lifelong learning and professional development, serving a global membership of computing professionals and students. I'm Will Trace, Lockheed Martin Fellow Emeritus, former chair of ACM SIGSOFT, and past member of the ACM Professional Development Committee. For those of you who may be unfamiliar with ACM or what it has to offer, here's more information. ACM offers educational and professional development resources that bolster skills and enhance career opportunities. You can see some of them on the highlights on your screen. ACM provides access to the ACM Digital Library, the world's most comprehensive database of computing literature, leading publications and global conferences that draw top experts on a broad spectrum of computing topics, support for education and research, including curriculum development, teacher training, and the ACM Turing and ACM Prize in Computing Awards, and the ACM Code of Ethics, a collection of principles and guidelines designed to help computing professionals make ethically responsible decisions in professional practice. Before we get started, we'd like to quickly mention a few housekeeping items shown in the slide in front of you. If you have any questions at any time, please type them into using Zoom's Q&A button. We'll organize the questions, and I'll ask Scott to try to get to them as many as possible. This session is being recorded and will be archived. You'll receive an email notification when it becomes available, and check learning.acm.org for an updates on this and other upcoming webcasts. At the end of the presentation, you'll see a survey open on your screen. Please take a minute, fill it out to help us improve our Tech Talks. Today's presentation is Testing the System, a holistic approach to security and systems developed by Scott Tilley. Scott is Emeritus Professor at the Florida Institute of Technology. He is the president of Big Data Florida, the Center for Technology and Society, Precious Publishing, and Space Coast Writers Guild Fellow. His recent book, including Adaptive Poetry Systems, Analysis and Design, Poems on the Moment, Aftermath, and Pets. He holds a PhD from computer science from the University of Victoria. Scott, without further ado, I'm looking forward to this talk. Take it away.
Thank you, Will. Everyone can hear me okay? All right. Yes, well, good afternoon, everyone. So I'm very pleased to be able to talk to you a little bit about some of my thoughts about system testing and a holistic approach. Before we begin, however, people often ask me, where do I live? And I live in Melbourne, Florida, which is known as the Space Coast. It's shown there on your screen. So Melbourne is just south of the Kennedy Space Center. And if you see the two pictures on the right, they're pretty much what happens with the Falcon 9 launches almost every day. That one in the middle are the Falcon 9 boosters during one of their dual landings. It is very loud, multiple sonic booms, and really spooky when you see these things land. The one on the right actually just happened very recently. That's Blue Origin's New Glenn launch. No screen. Maybe someone could tell me if you can't see my screen or not.
I can't see your screen, Scott. This is Will.
Hold on.
Jan, if you want to jump in. Got
it?
There we go. Fantastic.
All right, let me just hit the read button. So as I said, welcome again. Sorry about that. I had to restart earlier. So I'm very pleased to be talking about testing the system, and I wanted to show you a little bit of images of where I live. I live in Melbourne, Florida, which you see, hopefully you see now, which is on the map there. Melbourne is on the east coast of Florida, just right by the ocean, just south of the Space Center. And those two images you see there is something that we get to experience here very frequently. I think there's a Falcon 9 launch or two almost every day. That picture is of two of the boosters when they're coming back, which create sonic booms. When I first saw it on video, I thought it was like, the invasion from Mars. It is really spooky. And on the right is one of the latest additions to the Space Coast launch schedule. That is Blue Origin's New Glenn rocket, which went up, I think, last week. It's quite large, 320 feet or so. So there's a reason why this is called the Space Coast. There's launches almost every day. And if you look at me, you can see I'm wearing a couple of sweaters. So welcome to the Sunshine State. This was a picture taken 2 days ago in Pensacola, which is north of where I am, but I never thought I would see the day where it was snowing and people were sledding in Florida. But there we are. Strange weather indeed. All right, on to the topic at hand for today. The motivation for talking about this is sort of threefold. First is the threat landscape is certainly evolving very rapidly. They are increasingly sophisticated cyber attacks targeting vulnerabilities across systems and people and processes, hence the holistic approach that's required. These attacks definitely having increased organizational impact. They can cause financial loss, reputational damage, legal consequences, and a variety of other things. So they've gone from being an annoyance to being something that is serious at the enterprise and corporate and institutional level. And lastly, I believe that there's a critical role to integrate security testing across the system development lifecycle, the SDLC, everything from design to development to deployment. And this is not something that we've really been doing, I don't think, properly yet. So we'll talk about that a little bit. So the talk today is, I want to give you a little bit of definitions of some of the terms we're using. Walk through five different areas of security testing, and then go through some real world examples, just a couple, and a little bit of best practice that I see that might come out of some of this discussion. So I have to say that a lot of material that we're talking about today is coming from the most recent edition of my book called Systems Analysis and Design. This is the 13th edition that was published this past August. You can contact me or just Google it, or there's the URL if you want to grab a copy. A lot of the material from today is from chapter 13 and a little bit from chapter 12. So I have a few examples and screen images and so on from that book. So I wanted to sort of go to the source, if you like, when we talk about these very basic terms. First is, what is testing? And I went to ISTQB, the International Software Testing Qualification Board. And it just says the testing is a process within software development that evaluates the quality of a component or system and related work products. Now, of course, that definition begs a lot of questions about what is quality and how the evaluation is done, but we'll use that as a baseline. For the word system, I use the NCOSI definition, which is an arrangement of parts or elements that together exhibit behavior or meaning that is that individual constituents do not. And a system can be either physical or conceptual or a combination. So that part is very important for a system rather than, say, a software application, because we're talking about something that is working in concert with other applications, programs, and its operational environment, which includes people and other things. And when I talk about holistic, the definition here is from the Oxford English Dictionary. It's talking about something that is interconnected, and it can only be explained by a reference to the whole. In this context, we are referring to the fact that testing must be applied across the entire domain. So just to sort of make that concrete, we're talking about technology components, usual hardware, software, networks, and so on. We're also talking about the processes like workflows, and think about your own personal workflow for doing daily tasks, technology or otherwise, and procedures that govern how the system operates. everyone involved, the key stakeholders, everything from users to administrators that interact with or depend on the system and its operational environment. So again, in this context, the system isn't just technologies, not just software. It's the entire ecosystem where all of these things converge, hence the word holistic. So this to me is very important because it really identifies what's different between a system approach and say a software testing approach to a smaller scale issue. Some of the issues related to holistic approach, for example, talking about interdependencies between components or between actors. We talk about organizational layers, and they could be things like policies, because we'll be talking a little bit about governance and compliance, user behavior, safeguards, external risks, which are critical when it comes to cybersecurity, and long-term impacts that would include organizational damage, financial impact, and so on. So really, we're talking about testing the system in the big picture, the integration of technology, people, and process running in an external environment, and trying to address cybersecurity using a unified strategy across all these areas. This simple figure is just a variation on what I'm sure most people are familiar with of just a classic waterfall-like model. It's still very common in the systems world. This is taken from chapter 1 of the textbook I referred to. We refer to it as the SDLC from historical purposes. It has 5 phases from planning, analysis, design, implementation, and operations. Today, we're primarily talking about operations with a little bit about implementation. And the last aspect for the introduction is this CIA triad of confidentiality, integrity, and availability. I'm sure those who work in cybersecurity are eminently familiar with this figure, but it does provide a good foundation to discuss security testing, because whatever we're addressing and the different approaches the 5 will talk about do indeed address one or more aspects of security, whether or not we're maintaining confidentiality, that is making sure the sensitive information is accessible to only those who can have the authority to view it, making sure that the information is accurate, integrity, and making sure the resources are available as needed. All of those, of course, perform important roles in testing. They also are opportunities for exploit. So I want to talk now with that as a background about 5 different security testing areas. And we're going to go through each one of these in turn. Risk-based testing, which is leveraging risk identification, assessment, and control to prioritize testing efforts. Frameworks compliance testing, that is ensuring alignment with some standards such as ISO, NIST, and others. And this becomes particularly important at the enterprise level, and especially when companies are going through audits, for example, legal situations, then compliance and GRC people enter the picture. Advanced threat testing, which is something that's become increasingly important these days, and that is advanced persistent threats. For example, in the news recently is about nation states lurking in our communications infrastructure and revisiting it periodically every 6 months. That's an example of a sophisticated, advanced, persistent threat. Continuous testing and monitoring shares a lot with continuous development and operations. But in this case, we're doing testing and monitoring from a testing and possibly a compliance point of view. And arguably the most important from a system point of view, which is human-centered testing. That is addressing vulnerabilities tied to social engineering, insider threats, and basically the workflow of the user as they walk through some of these tools. So let's talk about the very first one first, which is risk-based testing. So risk-based testing talks about identifying, assessing, and prioritizing potential threats based on their likelihood and their impact. Now, people do risk-based testing outside of cybersecurity, of course. You can do it for any large system. It doesn't have to be software or cyber, but of course it's applicable in this world as well. So we usually go through at least 3 key steps. That is risk identification, where we pinpoint vulnerabilities, software bugs, misconfigurations. We then do an assessment, which evaluates the threat likelihood, and we rank them using some sort of priority mechanism, and the impact using tools like risk matrices. And then we apply strategies like avoidance, mitigation, transference, or acceptance to minimize these risks. Why this is important is it ensures that what we identify as critical vulnerabilities are identified and addressed first, and we optimize our resources to reduce the potential for catastrophic failures. It should go without saying that all the different security testing areas we're talking about and all the other software and system security testing mechanisms will never, of course, preclude attacks, vulnerabilities, or exploits. What we're trying to do is mitigate and minimize the impact. When we think about applying risk-based testing, as I said, we have a 3-phase approach of identification, assessment, and control. And we have different strategies for each one of these. So control strategies like avoidance. So in a hardware sense, a firewall would be an example of trying to avoid a network vulnerability. In a software or governance situation, we can have restricted access. From a mitigation strategy, we can reduce the impact. For example, we have a disaster recovery plan in place. Transference is when we're shifting risk to third parties, for example, insurance. We can just choose to accept the fact that we will have some level, in this case, an acceptable level of risk. And if something happens, we have an insurance policy in place. A tried and true approach to dealing with exploits and catastrophes. And then acceptance. We may agree to accept minor risks when unavoidable. Very similar to we may accept that we will ship software with known level of known bugs, which we will fix later. For example, in a technical debt scenario. So the benefits of doing risk-based testing and application is that these do align with the CI triad, and they help maintain security and resilience against threats that evolve over time. The second testing area that I want to mention is compliance testing. So the definition of this is when we have a compliance testing that ensures the system meets some level of security standards and industry benchmarks, like the ISO 27001 standard for cybersecurity, the NIST cybersecurity framework, the DSS framework, which is used for doing credit card and other financial transactions, and so on. There's many, many standards, which is one of the problems, of course, but they often come into play when it comes to expert witness, litigation, legal oversight by government bodies, and so on. The key elements of compliance testing would be gap analysis, identifying weaknesses in the system relative to the framework's requirements, and then prioritizing testing efforts on areas that are critical to compliance and risk. To me, this is really, really important because inheritance to security frameworks can be heavyweight. Many people don't like going through a compliance or an audit, but they do build some level of assurance that the system is in adherence with commonly accepted standards. It does help build trust with stakeholders, and in our current environment, ensures legal and regulatory compliance. And if you know folks who are in governance, risk, and compliance, like a GRC cybersecurity analyst, this is their bread and butter. And this is becoming increasingly important from a system point of view due to the complex and significant nature of cyber attacks and breaches. To apply compliance testing, we have certain processes and tools in place. As I mentioned, we can use gap analysis. This is an instance where configuration management, which is chapter 12 of the book I mentioned, discusses things like maintainability during updates. That's where software activities like regression testing would take place. And also make sure we're conducting periodic testing to make sure your systems are aligning with standards as they evolve. All standards change over time. So one example of this, for example, would be, say, a retail organization. They can achieve DSS compliance by testing and auditing all their credit card transactions, possibly by a third party. That becomes very important when it comes to, actually, it's in the news lately of overcharging based on transaction fees. The third security testing area is advanced threat testing. So advanced threat testing is about identifying and mitigating threats like advanced persistent threats, or APTs, such as social engineering, think Kevin Mitnick, and insider threats. This sort of threat, besides human-centric testing, in my opinion, is one that's becoming one of the most challenging to defend against, because these are attackers who are taking or playing the long game. They're very long term, they're very stealthy. An example that we don't have time to talk about in detail today, but I'll just mention, would be the SolarWinds attack. That was a supply chain attack that was very long term, very stealthy, and was very difficult to identify and then to mitigate. Now that took place in 2019, 2020, but there's other instances of it more recently. We have social engineering, that would be manipulative attacks, and by far one of the most common attacks right now for introducing malware is phishing and baiting. And they target human vulnerabilities. That's, read this mail, click on a link, and boom, you're infected. And of course, insider threats. That's when you have misuse by employees or contractors who, in fact, have the ability to access material and they have the rights to do so, but they misuse that ability. So this addresses technical issues, technical vulnerabilities, and the human element, which is almost always the weakest link in security, as we all know. But it's important to monitor this because it's an increasingly sophisticated approach to penetrating systems. Now, how advanced threat testing can be applied? Well, we can actually employ things like machine learning and AI to detect anomalies. Credit card companies, financial companies use it all the time to detect, for example, fraudulent or out-of-the-ordinary transactions. We can do the same sort of thing, which has been done in many agencies over time, to detect unauthorized or periodic out-of-the-ordinary access to systems or data. We can do simulated attacks like phishing simulations and social engineering tests using, so-called white hat attackers to identify vulnerabilities in the system or through the people. We can leverage data on what's called TTPs, that is tactics, techniques, and procedures, to anticipate and counter these threats. And very important, identify appropriate training programs to identify and equip employees with the knowledge of how to recognize and report activity and avoid phishing attacks and so on. Your organization or your university is probably flooded, mine is, all of them are, with weekly emails about the latest phishing attack and how to avoid it, and a reiteration of not to click on links you don't know and trust. So there's obvious benefits to this, of course, improving resilience against especially state-sponsored attacks for these long-term attacks. Building organizational awareness, being a security-aware organization, is also very important. So this helps build that awareness and builds proactive defenses through these intelligence-led testings. The fourth area is security testing is continuous testing and monitoring. That involves ongoing processes to identify, assess, and address vulnerabilities in real time. So some of the key components of this are fault management, where we detect and resolve system errors. We do capacity planning, for example, to identify risks needed to prevent performance bottlenecks. That might be done as well during system maintenance if we're considering enhancements to the system. We of course can run vulnerability scanners. We've been running, antivirus software forever. These will be more sophisticated versions of that. And emerging technologies come into play here, things like AI defenses and resilience through cloud computing and other distributed resilient systems. So this is important because it ensures proactive detection and helps improve system stability. So if you're working in resilience and accessibility, not from a user point of view, but from a from a system point of view. That's important. As I mentioned, we can use intrusion detection systems, or IDS, automated tools, including AI. We, of course, have to do things like assessing and patching vulnerabilities. That is also an issue. That was one of the exploits for SolarWinds. It was a patch that was exploited as part of their workflow, their supply chain. And we have to be able to equip the staff again with the abilities to maintain and monitor all these things effectively. The benefits: improve resilience, improve performance, minimal downtime, and increased organizational awareness and a security first mindset. And the last security testing area I want to briefly mention is human-centric testing. So this focuses on addressing user-based vulnerabilities, ensuring the systems are secure and user-friendly. And I understand that from a requirements point of view, making a system secure and usable are the classic examples of something that are polar opposites. Nevertheless, it's a constant tug that we have to address. And we're trying to reduce risk from either human error or human manipulation. So some of the key areas here are user training, defenses against social engineering attacks. I mentioned Kevin Mitnick, his classic book on social engineering. It should be must read, I believe, and other books are related to it. And mitigating insider threats. Some of the most insidious attacks can be from insider threats. They're very hard to detect. They're unfortunate when they occur, but they can be devastating when they do, given the level of access in terms of the CI triad that these people would have. Some of the testing, some of the ways we apply this, we have a lot of training programs that are necessary to bring people up to speed. I mean, one of the constant themes we'll see here near the conclusion is these systems are, all the systems we use these days are complex, sometimes needlessly so. So we need training to help people properly navigate the use of these systems, which their job, their livelihood, which their daily life depends upon. Go through simulated phishing attacks and so on. We revisit access controls and role-based permissions to limit access. This is something that is done at the enterprise level and increasingly at the commercial level. And again, use behavioral monitoring techniques. Benefits here, again, building a security conscious culture. I have two examples here. These are all public domain. They were discussed in the textbook a little bit. You know, unfortunately, if you read or follow that long standing forum about the risks forum that's been out from the ACM forever, you could spend all your time reading about security vulnerabilities and exploits. So these are just two. One affected Capital One, the credit card financial company, in 2019. What happened was, at the time, a misconfigured Amazon Web Service, AWS firewall, allowed an attacker to use insider credentials to gain access to sensitive data over 100 million customers. I believe they finally settled, but it cost them about $190 million, if I'm not mistaken. So a severe reputational hit, financial hit, legal hit. Some of the security testing areas that were affected or related to this: risk-based testing. The misconfiguration wasn't flagged as a high priority risk, probably because it wasn't known. And human-centric testing. The security testings to access the AWS system weren't tested from an ease of use or an error prevention perspective. And there's no doubt these cloud-based security systems and enterprise systems are complex. Therefore, we need to up our game in terms of ease of use and error prevention when it comes to those systems. It could have been avoided or at least mitigated had we performed risk-based testing as we just described, and some human-centric testing, and identified training programs that were appropriate to help staff stay up to speed on configuration management, security, and providing some proper documentation for everyone who gets onboarded onto these systems. The textbook at the end of every chapter has something called ethical issues. It's a question that I wanted the students and the readers to think about And this is verbatim taken from chapter 13 on managing system security. And as you'll see, is directly related to the Capital One example. It has to do with the fact that, there's a hypothetical system analyst who's uncovered a significant data breach. And you know that it threatens personal information and thousands or millions of customers. The company may proclaim a commitment to transparency, but the leadership is delaying informing the affected individuals because they rightly fear reputational harm and financial implications. So then you as the engineer are in sort of an ethical dilemma. Do you have loyalty to the company, or do you have a moral obligation to protect your customers' rights and your own reputation? What do you do? So this ethical situation really illustrates the tension between real world operational urgency, ethical transparency, and system testing. It says we need system testing to identify these, but we also need beyond that a broad system view of what is the organizational policy for identifying these errors, reporting them up the chain, resolving them properly, and then understanding the broader business and corporate implications of whatever decision are made. So this is why these problems go beyond simple software. They really extend to everyone, as I mentioned at the beginning, a holistic perspective of the issues at hand. The second example I want to mention is much more recent. This was from last July, and that was the outage at CrowdStrike. So CrowdStrike is a software application that helps manage patches and updates and so on Windows-based systems. And CrowdStrike software for this is called Falcon. And when they rolled it out, it affected Delta Airlines and many other airlines worldwide. For example, just Delta, I think, had to ground 7,000 flights. The issue stemmed from partly supply chain vulnerabilities, but partly poor testing. And the security testing areas that were relevant to this are continuous testing and monitoring. There's no doubt that you can do a deep dive now. A lot of this has been publicly documented, that the update to the system was not thoroughly tested. And you can understand why if you identify what is called a zero-day exploit, a critical vulnerability. There's again tension between shipping it, testing it, and shipping it, or delaying it. In this case, it wasn't thoroughly tested in all criteria and then pushed out through automatic update mechanism to all these systems, not just the US, but worldwide. And from a human-centric testing point of view, there was not a lot of real-world scenarios that involved airline critical systems and what to do when something like this might happen. It could have been avoided or at least mitigated if we had more comprehensive pre-deployment testing, including simulations for high-risk operations like airlines. Now, airlines are arguably not quite life critical, but they are safety critical. They are certainly global in reach. Because if you remember last July when this happened, and all of a sudden news started going around the world that flights were being delayed, terminals were being shut down, the airlines were wondering how to do everything by hand, all due to this one flawed software push out. So continuous testing and might have helped with this. So we have another ethical issue, and this is related to chapter 12 in this case of the book called Maintenance and Support. So think of the following. It's very much like the example I just described to you. A critical security patch has just been developed to address a significant vulnerability. Usually your team conducts thorough regression testing to ensure they don't introduce new bugs or issues. I mean, this is classic software engineering and testing 101. Doesn't mean it's always done, but it's part of our best practice. However, due to pressures to meet tight deadlines, your manager says, as a Dilbert cartoon may say, just ship it. So skip the regression testing, proceed directly to shipping the updated product. You as the analyst and engineer have to consider the potential risks to product integrity, customer trust, again, your own reputation, and in this case, literally worldwide implications. How do you respond to your manager's request? And you have to think about your own career. What stage are you at in your career? Can you afford to say no? Should you get legal involved? HR? Do you stall? Etc. So this scenario really does highlight the importance of prioritizing the risks of prioritizing speed over quality. It illustrates the importance of incorporating testing throughout the SDLC, and it illustrates how a software engineering failure, in this case, a faulty patch that wasn't tested before it's shipped out, manifests itself as a cybersecurity attack. Because I remember myself, I was sitting as I am now, watching everything happen. It was happening first here, but mostly over in the UK and Heathrow going crazy. And everyone assumed it was a cybersecurity attack, and then everyone got involved with that mindset. But in fact, it wasn't, but it manifests itself just like it. So we have two examples here where the problems are widespread, severe, yet could still benefit in both cases through using one or more of these 5 mechanisms. So a couple of slides now on best practice based on those and other testing techniques. One is you have to balance speed with rigor. We understand in modern systems, deadlines are important, but cutting corners in testing can lead to great delays, financial loss, and reputational damage in the long term. And I'll circle back to the slide I showed you about living on the Space Coast here in Florida. Every company here is pretty much involved in aerospace or defense. So it's very much a systems engineering community. And it's very common for launches, especially new launches like the new Glenn that went up recently, to delay right near launch and postpone because they have a flaw. They can't afford to just so-called ship it. They can't launch because of the implications, corporate life, reputational and otherwise, of just shipping and having catastrophic failure. So I think many of the other parts of the software and system world could learn from that best practice, even though there are costs associated with it. The second is to prioritize risk-based testing, to learn from other areas that prioritize risk, like the insurance companies. You have to test the most critical components because we know from classic testing you can't test everything 100%, and reduce the impact of missed deadlines without compromising security as much as possible. And third, I believe this is important for an organization like we're all part of as professional computing organizations. Organizational policies must align with ethical guidelines. That means professionals must be empowered to make decisions that prioritize safety and trust, not always over ship it, profit. That's very important when you get to large scale systems. Less so, the classic example is, if your app fails, you just restart it. If your control system for spacecraft fails, it's catastrophic. So the priorities change. The second practice is a little more lighthearted, but equally important. The first is, well-known saying from Microsoft and others, and that is, eat your own dog food. And this is one of my bugaboos that I'm constantly complaining to people about. And is I often wonder if the CEOs or the presidents and so on of any organization actually use their own products the way they expect people to use them in the field in a normal workflow. The first example is something that's not software related at all. It is whenever you buy something, say at the hardware store or the grocery store, and it comes in one of those hard packages that you have to get out an X-Acto knife and a pair of scissors to cut open just to get out something simple. It's nearly impossible. You might think, well, it's packaged there for your safety, but you ever thought about people who have mobility issues, the elderly? What if you have only one good hand? If you really want to step up, try opening one of those things with one hand. It's impossible. The second is something that is computing related, and that's related to cybersecurity definitely, and that is what's called two-factor or MFA, multi-factor authentication. And that's, of course, when you log into your bank, for example, and instead of just getting a password, you get a password, you log in, then it's going to text you with a special code to your phone, or it may use some other biometric. And individually, these are an annoyance, but they're an acceptable annoyance because you know you're somewhat improving security. The problem is when you put these MFA or other multi-factor authentication mechanisms in place in a system. So a couple of weeks ago, I was making hotel reservations. And to do that, I had to go to the hotel, the airline, the bank, and the taxi, the rental service. And each one of them, three of the four already had MFA in place. The fourth wanted me to add it. Each one is different. Therefore, to do a simple workflow, I had to constantly switch apps, set up new MFA mechanisms. And at that point, I feel like I was on hold through a ridiculous call tree. So an MFA in an instance on one app is not bad. When you put it as an overall workflow, that's how a user will actually experience it. It's unusable. It's that security usability trade-off, which speaks to point number two. You know, the saying eschew complexity, that means avoid complexity, tongue in cheek. Complexity is the bane of security, and our systems are only getting more and more complex, which is how some of these sophisticated advanced persistent threat instances are becoming more enabled because our systems are so complex, we barely understand them. And third, well, I took a picture. That's my mother. She passed away a few months ago, but she always amazed me as someone that every time I gave her a new piece of software, basically hardware, and she would hold it in her hand or look at it and then ask me a bizarre question or use it in a way that I never thought of. And I look at her and say, who would ever do that? And she would just look at me saying, well, that's what I want to do. I thought, right, you should be hired by every major software company as their testing maven because you think outside the box. You're thinking about how to use the system in ways that developers, engineers, everyone involved, and the typical stakeholders never think of. In other words, they are proxies for attackers who look for vulnerabilities that are known or just outside the box. So those are three best practice I would suggest. So to wrap up, if you don't know that, that's from Star Trek 2, of course. That's Spock saying, remember. Remember that regular software testing is still essential. So everything we're talking about here is system testing. Doesn't obviate the need, of course, for traditional software testing, for functional and non-functional testing, and all the other quality attributes that are discussed in that field. The second thing to remember is a systems perspective is critical for addressing cybersecurity and security in general for these interconnected complex systems because it cuts across human, technical, and organizational elements. And third, as I just mentioned, think like the end user. Security testing has to consider real world context, actual workflow, and user behavior. This helps uncover hidden vulnerabilities. So they're absolutely necessary. And I'll take a few questions, but I do have, as Steve Jobs would say, one more thing. And that is something I didn't discuss at all, but it's the elephant in the room. And that is, what about AI? How does this affect this whole field? And the answer is a lot, and I'm not sure. And of course, that quote on the bottom there is paraphrasing President Reagan when he said, the 9 most scary words in the English language is, I'm from the government, I'm here to help. And I would paraphrase it as, now I'm from the AI and I'm here to help. That's a topic for an entire set of different talks related to how AI can help or hinder the cybersecurity work, the testing work, of course, is being deployed in both of those areas. I already alluded to some of them in terms of continuous monitoring and threat modeling. So when I said standards evolve, approaches evolve, the field evolves. And of course, I'm using OpenAI here as a proxy for all AI companies and approaches. So something for us to discuss perhaps in the future. So with that, can have an AMA session as much as you're able, and I'll welcome any questions.
Thank you very much, Scott. Hey, listen, you just hit the biggest nail on the head on your way out the door. I had my questions ready to go, and I first will start out and say thank you to all those listeners who provided questions. I can tell by the quality of the questions that you were very impressed with Scott's talk. With that, I must say, Scott, if you have a chance, could you put the name of your book up that you were referencing? Once again, there were many requests that people know exactly. There it is.
Bonus questions if you can guess what city that is.
Pardon me?
Bonus points if you can guess what city is on the cover.
Okay. Um, let's see. So, as I said, you hit the nail on the head just as you were closing, as I was lining up the questions about AI.
Yeah.
And I will ask two questions that were very popular, upvoted. How about reverse? How is AI being used against attack vectors? What are the current trends? And the second question was, is AI threat detection essentially based on training the AI on past threats? If so, can it detect new, never before seen threats? And can you elaborate a little bit on AI threat detection? So,
Okay.
thank you.
Can I just punt and say that'll be another talk? No, I'm not allowed to do that. Um, so as I said, so it is being used already. Yes, we are using companies. I'll use Palantir as an example, a very popular, well-known company that's been employing AI for cybersecurity threat detection and mitigation for a while. So you probably know the analogy. If you think about traditional computer antivirus software, it looks for fingerprints, traditional patterns that you could match against. Then over time, as the threats became more complex, we had to have adaptive antivirus systems that are able to identify patterns of behavior, not simple fingerprints. But you still need to know a little bit about the patterns. AI systems, as if you can use, an LLM-like model, can learn from system behavior and therefore build up, you might say, a portfolio of threat vectors, new threat vectors. And if you're looking at from a defensive point of view, new attack surfaces for your system. So it's certainly an emerging area, but yes, we're using it for both detection, prevention, but that means like a chess match. It's also being used for exploit. There was an article 2, 3 weeks ago. It was a front page article, I think in the Wall Street Journal, and it was about a tiger team or red team at Anthropic, one of the big AI companies, using multiple instances of their Claude AI system, which is like ChatGPT, and to launch basically a penetration testing exercise against other simulated systems so it could identify um, vulnerabilities that were unknown. And it came back within a very short period of time with unknown vulnerabilities with detailed examples of how to exploit them. So powerful and scary at the same time.
Thank you. Do you have any comment on paid penetration testing, pen test?
Yes, I mean, I think they're valuable. I mean, people have been using paid penetration testing, very much like bug hunts, right? Paid bug hunts, which companies have been using forever. It's because you're done properly, and we're talking about like sort of white hat, not off the black market penetration testing. Then you're identifying vulnerabilities that, again, second set of eyes, so to speak, can identify. It's basically you're hiring my mother, so to speak. Um, the flip side of that, again, when we're talking about security, there's pros and cons, and the con is there's a thriving third party market for hiring tools and people for doing penetration testing on systems and then exploiting the system.
Okay, I just sorting through things here. What is the difference between a threat and a risk?
Hmm. So to me, I mean, a risk is something that is inherent in the system itself, and that's why we can do a prioritization of these risks. A threat is something that is possible that is going to exploit that risk. That's the way I think of it.
Okay, okay. Now, abstractly speaking, because this question, why do you think security and usability are necessarily opposed?
Oh, the classic example I used to give students is if you want to create a highly secure system, you put it in a closed box, with no network connections. It's fully air gapped. It's totally secure, well, mostly secure and completely unusable. That's the classic example from software engineering.
Right.
Um, the more you provide access to a system, then almost always you're providing access. Therefore, an access point is a potential vulnerability. That's why usability and security are constantly at loggerheads. I don't know that there's a good way around it anytime. You provide access, you're providing a way for an exploit to be introduced in some way.
Okay. Okay. Well, this is a two-part question that I'll read slowly. Is there one or many methodologies to start onboarding software engineering and the quality assurance department teams in this testing mindset? That's the first part. And also, are there any sources or tools to implement along with other testing strategies without overdoing duplication?
Okay, well, the first question has to do with onboarding. I think you said about, say, the engineering team with some of these testing and security stuff.
That's right.
Okay, then yes. I mentioned, ISTQB. That was the one I took the definition of testing from. So that's an international organization. There's national variations or instances of it. ASTQB is the American Software Testing Qualifications Board here. So anyone can go there and download their syllabus for doing and taking courses and being certified as a software tester and related exams. So if you already have an engineering background and you want to get up to speed on traditional testing, for example, you can. They have other specialized exams on mobile testing, AI testing, and so on. So there's ways, that's just one example. There's other sources, open source, free, Udemy, LinkedIn, to just name a few. There's all kinds of sources where you can go from one engineering discipline to come up to speed to another. That would apply to cybersecurity as well, of course. So there's lots and lots of ways to do onboarding that's either internal, in-house, or external. The second question I think was related to the tools. Well, the tools, there's many, many tools like there are in almost any other application in software and systems. Some are quite specific and, the examples of things like the Falcon tool that is used, that was problem. These are complex tools for complex problems. So they also require training on onboarding to use properly. They usually require restricted asset access because they do have the ability to monitor and potentially alter sensitive data. So there's plenty of tools, but they're a little bit different than just onboarding at the sort of entry level.
Well, to follow up with that, there was a question that came in just recently. Do you recommend some open source software tools for security testing? And one of the listeners commented Burp Suite is one of their favorite tools, but do you have any
Yeah.
other tools that you might recommend or are aware of?
There's a lot. If you want, I can maybe send you guys a list in the chat or to the ACM afterwards. Purposely you mentioned is one that's most commonly used. There's a pile of commercial ones. They tend to be enterprise level rather than individual user level. So that we're not talking like unit testing per se. They're more system level tests and beyond. Um, but Perp Suite and a few others are open source and available. But again, if you want a longer list, I can provide them after.
I think that would be appreciated. That's a standard operating procedure for these
Yes.
webinars.
Mm-hmm.
And let's see, another question that just came in. Would you agree it's almost more dangerous for someone like an engineer who thinks they understand security, trying to do it themselves? For example, rolling their own solution and trying to defer to experts and not to pretend to do security myself. So, an honest question asker.
Um, I would mostly agree. And the analogy would be a software engineer who thinks they understand encryption better, so they're going to develop their own encryption algorithm. When there are well-known, well-tried, community vetted algorithms and their implementations. Security is something that is in itself complicated and can be exploited. Security software and security mitigation tools. So before you go off and invent your own, look around, see the previous questions about onboarding and also tools that are available. Then do your own gap analysis. I mentioned gap analysis earlier on in the talk to find out if there's nothing that's available that would suit most of your needs before you go down the rabbit hole of developing your own new technique, developing your own tool, which at the end of the day will take a lot of resources and may or may not be as good as what's available already.
Very good. Okay, well, the final question, which I've been holding back, waiting for new streams of questions to come in, but so what is the city that's on the cover of the book?
That is Bangkok.
And what is your connection to Bangkok, if
My
I may
connection is none. It's picked by the publisher.
ask?
I just think it's an
Okay,
improvement over the
last
previous
question
ones.
then.
So,
Any comments on system or software design methods that can make security testing easier? And one of our readers suggested Dev Security Ops is available.
yes. If you're familiar with the phrase in testing, shift left is where you keep wanting to move the focus and the applicability of any testing tool or technique closer to out of implementation, then to requirements, then to design. That's the shift left in the traditional waterfall lefting. The same thing would be here. So something like DevSecOps is shifting the security mindset from not something that is only during deployment and not something during audits when something went wrong, but it's moving it all the way to the design phase where people are thinking about it security first. Um, there's only good things that can come of that because you're addressing things right up front and thinking about every possible requirement, for example, that you may be satisfying, what impact that might have on other requirements, which have a knock-on effect on implementation and therefore possible security exploits. So all these things do have links in a traditional requirements traceability point of view, but shifting left even on this, very beneficial.
Thank you. Okay, well, I'm afraid we have run out of time today. I'd like to thank Scott again for his informative presentation and insightful answers to the many questions. And a special thanks to each of you for taking the time to attend and participate today. This talk was recorded and will be available online shortly at learning.acm.org. You can find announcements on upcoming talks and other ACM activities at learning.acm.org and acm.org. So in closing, please, we'd appreciate it if you fill out the quick survey where you can suggest future topics and speakers, which you should see on the screen now or in any moment. On behalf of ACM, Scott Tilley, and myself, Will Trace, thanks again for joining us, and I hope you will join us again in the future. This concludes the talk.